Right, good morning everyone. Right people, today we're going to do differential calculus. Now differential calculus is a lot of marks. It is found in paper 1 and it's approximately 35 marks in the exam. Now there are certain questions that come up in every exam. The first question in differential calculus will always be to differentiate by means of first principles. The second one would be to differentiate, that's around about 4 to 5 marks. To differentiate by means of rules, around about 7 marks. To find the equation of a tangent to a curve, another 3 or 4 marks. And then you've got to draw the cubic graph, or the cubic graph will be sketched, and you have to answer questions on it, that's another 15 marks. And then you're going to get application of calculus. So, today I will focus on rules, which is 7 marks. And I will start first principles, and that's 4 marks. So more or less, people, we're going to do 12 marks out of the 35 today. All right. So if you work with me, those 12 marks everybody needs to get, because you will see it is quite easy work. All right. But in order for me to do differential calculus, I need to explain certain concepts. The first concept is the concept of a limit. Now people, what is differential calculus? It is a mathematical tool used to make complex calculations easier. It is used by engineers, by mathematicians, and it is, if you take mathematics at university, you're going to do calculus. And then you're going to do calculus, and the reverse of calculus is integration, right? Then in the first year, you will work with real numbers. In the second year, you will work with differentiation and integration of complex numbers, all right? In my year, that is what we did. It doesn't, I don't think it's changed very much. Let's have a look at the following. What is a limit? Now people, if I've got the graph fx equal to x plus 1, there the graph of f is drawn. I'm excluding 3. The reason for excluding 3 is I want to see what is the value as I approach 3. Is that clear? Now, let's have a look. If fx is a y value and fx is equal to x plus 1. Now people, if I've got fx equal to 2, what is my corresponding y value? I'm going to put x equal to 2 wherever there's x in the expression. So it becomes 2 plus 1 is 3. So the corresponding y value here is 3. It's not a very accurate graph. Is that clear? So if I go to 2, 5, now x now becomes 2, 5. What's my corresponding y value? So if it's 2, 5, if x is 2, 5, wherever there's x, I put 2, 5 plus 1, and that is equal to 3, 5. So my corresponding y value here is equal to 3, 5. Is that clear? So if it becomes, that's 2, 5, if it becomes 2, 9, what is my corresponding y value? So it is 2, 9 plus 1, which is equal to 3, 9. So if it is 2, 9, then this here becomes 3, 9. Is that clear? And if it's 2, 999, then I put 2, 999 into the expression, and it becomes 3,9999. Now people, have a look. The concept of limit is what value am I approaching? X is approaching 3. Do you see that? X is 2, 2, 5, 2, 9, 2, 99. X is approaching 3. As x approaches 3, what does the value approach? 3, 3, 5, 3, 9, 3, 99. The value is approaching 4. Correct? You understand that? As I approach for this function, as I approach 3, I am getting a value of 4. It's going to 4. Is that clear? It's approaching 4. So what is the limit? Now you've got to look at the notation of a limit. The limit of x plus 1. Now x plus 1 is this graph here, correct? And x is approaching 3. I am trying to find the value. If x is approaching 3, what does the value approach? That's the limit. So in order for me to find the limit All I need to do is, I need to put that x value into the expression, and I've got my answer, correct? However, the limit is not that value at the point. It is the value that I'm approaching. Is that clear? That's a limit. But how do I work it out? I just substitute it into the formula. The exception to the rule is, if I substitute this limit value into the expression, and it makes the denominator 0, 1 minus 1, 1 minus 1 is 0, correct? Then, if it makes it undefined, then I must first factorize before I substitute. Right, let's quickly have a look here. People, do you see I'm working at a limit? To work at a limit, what is the rule? Substitute this x value into the expression. And when I substitute it into the expression, the limit falls away. When I substitute this x value into the expression, the limit falls away. Is that clear? So this here becomes 2 times 1 plus 4, and the answer is 6. Are you with me? Right. So how do we work out a limit? We put this x value into the expression, and we simplify. The exception to the rule is, if I put this value into the expression, and it makes the denominator 0, then it makes it undefined. So what must I first do? I must first factorize. This here is the difference of 2 squares. When is it the difference of 2 squares? If I can find the square root of the first term, square root of x squared is x, the square root of the second term is 1. I repeat the terms, divided by x minus 1. Now, I factorize, I simplify, now I can substitute. So when you put x equal to 1 into the expression, you drop the limit sign, and the limit is 2. Are you happy with that? Have you got that? All right. Now, why am I introducing the limit concept to you? Because when I'm going to differentiate by means of first principle, the formula is the limit as h approaches 0 of fx plus h minus fx over h, and that is what I'm moving towards. Okay, so have a look. Again, people, we are busy with a limit. However, I want you to make sure that you understand how to factorize x cubed minus b cubed. Now, this here is the difference of 2 cubes, and that is the sum of 2 cubes. Grade 10 work. Let's just revise that. How do I factorize this difference and the sum of 2 cubes? The cube root of a cubed is a. The cube root of b cubed is b, and I keep the sign, correct? That's how I get the first term. How do I get the next part? I say the first term squared is a squared. The middle term is that term times that term. A times b is ab. And the last term squared is b squared, correct? And this sign is always the same sign. This one is always positive. And this sign is opposite sign. If this is a negative, this will be a positive. Is that clear? Right. So people, in this case, if we look at a cubed plus b cubed, then we can say the cube root of a cubed is a. The cube root of b cubed is b, keep the sign. And then the second part is a trinomial. Now also take note of this. In the sum and difference of 2 cubes, the trinomial part has got no factors. I cannot factorize that further. It's got no factors. It's non-real. Is that clear? So if you're going to solve for an expression like this, that trinomial, that part there, you can use the quadratic formula and see its non-real roots. Right. So if we got to find the next part, so then you can say it's a squared minus ab plus b squared. That is the sum of 2 cubes, and that is how I need to factorize it. Now, let us use the difference of 2 cubes to work out the limit sum. I said to you, when you want to work out a limit sum, all I need to do is to put this value into the expression. If it makes the denominator 0, and it does, because 3 minus 3 is 0, which means it's undefined. And I'm not allowed to do that. So what do I have to do first? I first need to factorize, simplify, before you substitute. So we can say it is the limit as x approaches 3. This here is a difference of 2 cubes. The cube root of x cubed is x. The cube root of 27 is 3, same sign. So it's x squared plus 3x. Remember, opposite sign. 3 times x is 3x plus 9 over x minus 3. That now cancels out. And I'm left with that. So to work out the limit sum, I'm just putting that 3 into the expression where there is x. So it becomes 3 squared plus 3 times 3 plus 9, and that is equal to 27. 9 times 3 is 27. Is that clear? And when I substituted x equal to 3 in place of x, I dropped the limit sign. Does it make sense? Are you all with me? All right. People, I am going extremely slow, but it's better that way because half of you haven't been taught this section of work before. So I hope that you are keeping up and that you are understanding. If you don't, please raise your hand. I will answer any question that you have. Let's have a look at the following. Now, people, now that I've introduced the concept of limit, I'm going to take the concept of limit further. For example, if I've got the gx graph, the gx graph is a parabola, and I want to find the average gradient. We know from analytical geometry that the average gradient is actually the gradient of the straight line. Correct. Average gradient is changing y over changing x. Is that clear? Which is equal to y2 minus y1 over x2 minus x1. Is that clear? Right. Now, if I put this x value into the g graph, I'm going to get the g of x. Agree? And I'm going to put x plus h into the g graph. I'm going to get the g of x plus h. Yeah, we did it in terms of numbers. People, I put 2x equal to 2 into the f graph, and I got my corresponding y value. I put x equal to 2 into the f graph, and I got my corresponding y value. My corresponding y value was the f of 2, correct? Where x is 2, the f of 2 was 3. Now, if this is x, this is gx. If this is x plus h, I will get a value of g of x plus h. Is that clear? Now we can say the average gradient is changing y over changing x. So it is this y value minus this y value. The g of x plus h minus the g of x over this minus this. Always the big minus the small, the big minus the small. X plus h minus x, which is equal to the g of x plus h minus the g of x over h. Does it make sense? Now, people, if this was the f graph, then this would be x, f of x, x plus h, f of x plus h. Then the formula would have been the f of x plus h minus the f of x over h. Is that clear? For the average gradient. Now, let's take that average gradient further. People, if average gradient is the gradient at any point, correct? Now, the gradient at a specific point is where I bring the limit sign into the equation. I am finding the gradient at a point. There, I want to find the point as x approaches 3. The gradient of the point is, yeah, you can say the g, this here, average gradient, but it's the limit of the average gradient. Gx plus h minus the g of x over h. So that's the gradient formula. And the gradient formula is the same as using first principles. So the gradient formula in terms of g is that. In terms of first principles, f prime x is equal to the limit as h approaches 0 of f of x plus h minus the f of x over h. All right. So I said to you, if this graph is in terms of f, then it is the f of x plus h minus fx over h. that part. And the limit means at a specific point. The gradient at a point is the same formula for using as first principles. If they say differentiate using first principles, I'm actually finding the gradient at a point. They are synonymous. Is that clear? To differentiate by means of first principles, this is the formula. It's on the formula sheet. And this formula is the same as finding the gradient at a point. Right, can you just nudge that lady there? She's having a good sleep. Right, people, have you got that? Are you with me? Right. Now, I am going to teach you first principles a little bit later. First principles is asked in every exam, 4 to 5 marks. And first principles can be asked for the expression fx is equal to a constant. Fx is equal to 2x plus 1, a linear function. Fx is equal to 3x squared plus 2x plus 1, quadratic function. Fx is equal to x cubed, a cubic function. And fx is equal to 1 over x, a quotient. Right. So they are going to ask you either a constant, a linear, a quadratic, a cubic, or a quotient. They're going to ask you to find first principles where any of these could be asked. 4 to 5 marks, and I'm going to do an example of each with you, but I first want to teach rules, because the answer that you get in rules must be the same answer that you get when you use first principles if you differentiate an expression. Is that clear? Are you happy with that? All right. So what am I trying to say to you? I taught you the limit concept. I taught you the average gradient. I put it together and I found a formula. I used the limit as well as the average gradient together will give me the gradient at a point, and that is the same formula for first principles. And then now, once you've got that formula, we will be able to differentiate a constant, a linear expression, quadratic expression, cubic, as well as a quotient expression, because that covers the full scope of the syllabus. Is that clear? One of them will be asked, 4 to 5 marks. Let us look at rules. People, I'm just going to ask you again, how do I work out a limit? I put that x value into the expression, and then my answer is the limit value. However, if you put that x value into the expression and it makes the denominator 0, what must I first do? Factorize, simplify before you substitute. Right, are you happy with that? Okay, now people, we're on the second page, rules of differentiation in your notes. Now, I'm going to cut the rules of differentiation only to 2 of these rules. If you use these 2 rules, you've covered everything. Let me explain. Right, thank you. Right, people, let's quickly have a look at this. I need your attention. Right. People, if fx is equal to kx to the power of n, this sign here, f prime x, is the derivative. Derivative. Now, what is the derivative? If that is the expression, the derivative is the exponent times the coefficient, which is kn. You keep x, you subtract 1 from the exponent. That is the rule. That is the rule that I need to apply if I want to differentiate. Fx is an expression. And when you say f prime x, means I am differentiating. That's the notation for the derivative. And what is the rule that I need to apply? The exponent times the coefficient. Then you keep x and you subtract 1 from the exponent. Now, to make things easy for you, let us do a few of those. We are going to say, now we're going to say fx is equal to 3x squared. Now, what is the notation I need to use for the derivative? Say it, f prime x. F prime x, that's the derivative, correct? So what is the rule? Exponent times coefficient. Exponent times coefficient is 6. Keep x, then subtract 1 from that exponent. The exponent is 2, subtract 1, answer 6x. That is the derivative. Is that clear? Now we're going to do a few of those. Then I'm going to show you that f prime x is only the notation if the function is fx. But if the function is y equal to 3x squared, then dy over dx is the notation for the derivative. Okay, before we get there, we're taking it step by step. Let us just reinforce this concept in terms of fx, and then we can look at the other notations for the derivative. Right. If I say to you that gx is equal to negative 6x to the power of negative 2, what is the notation for the derivative? G prime x. That is the notation for the derivative. And what is the rule that I must apply? Exponent times coefficient is positive 12. Negative 6 times negative 2 is positive 12. You keep x and you subtract 1 from the exponent. Now people, when they ask you to differentiate by means of rules, you can leave your answer with a negative exponent, unless they say, write your answer with positive exponents. And if they ask you to write it with positive exponents, then the answer is 12. And x to the power of negative 3, I'm going to take it to the bottom line. And that is how I change the sign of the exponent. Remember, let's look at the exponential laws. If we say 1 over x squared, if it's positive in the denominator and I take it to the top, I change the sign of the exponent. If it is negative on top and I take negative at the bottom and I take it to the top, it becomes positive. If it's positive on top and I take it to the bottom line, I change the sign of the exponent. Is that clear? And if it is negative on top and I take it to the bottom line, I change the sign of the exponent. So if this here is in the numerator and I want to write that exponent as a positive number, then I can take it to the denominator and the sign will change. Does it make sense? Are you with me? Okay. Are you happy with that concept, or do you want to do a few more? I think we need to do a few more. Is that fine? Right, let's look at number 3. Here we've got, hello? Must I explain this to you? All right, exponential laws. Right, let's quickly, I hit you in the middle of the exponential law. I hit you like rule 4 or 5 here. Let's quickly go through exponential laws quickly. Right, the first exponential law is if you multiply with the same base, you keep the base, you add the exponent, correct? That's your first exponential law. Your second exponential law is if you divide with the same base, you keep the base, you subtract your exponents. Are you happy with that? The third one, a to the power of m further raised to the power of n is a to the power of m times n. A base to an exponent further raised to exponent, keep the base, multiply the exponent. The other one is anything to the power of naught is 1, except naught to the power of naught, that's undefined. Now, those are the first four basic things. When we're working with negative exponents, we say a to the power of m. If I take that to the bottom line, I change the sign. That is the rule. And if it is negative on top, and I take it to the bottom, I change the sign of the exponent. That is the fifth exponential law. Okay, are you happy with that now? So what have I done here? I said, if it's positive at the bottom and I take it to the top, I change the sign of the exponent. If it is positive on top, if it's positive, I take it to the top, I change the sign. I've applied that. If it's negative at the bottom and I take it to the top, I change the sign. If it's negative at the bottom and I take it to the top, I change the sign. Are you happy now? It's negative. If it's positive on top and I want to take it to the denominator, I change the sign of the exponent. If it's negative, if the exponent is negative and I want to make it positive, I take it to the bottom line and I've made it positive. Does that? Right, that explains it. Are you happy with this now? Next. People, if you think I'm going very slowly, I apologize, but I need to take everybody into consideration. Right, let's quickly have a look at this. Are you all happy with this notation? If fx is the expression, f prime x is the notation. If gx is the expression, gx is the notation. Let's keep to that. Let's say, if this here is the f of t is equal to 3t squared plus 2t, correct? Now, what is the notation for the derivative? If this expression is in terms of t, we call it ft. And the notation is f prime t, correct? So now we got to use our rules for differentiation. And what is it? It is exponent times coefficient, keep t, subtract 1 from the exponent. Are you happy with that? I repeat, I am now applying this exponential law. I'm saying exponent times coefficient, keep x, subtract 1 from the exponent. I'm saying to you, exponent times coefficient, keep the t, subtract 1 from the exponent. Now, I say, I've got to find the derivative of that. So I say exponent times coefficient is 2. Keep t, subtract 1 from the exponent. So this becomes 6t plus 2, t to the power of 0. 1 minus 1 is 0. Anything to the power of 0 is 1, except 0 to the power of 0. So this here becomes 6t plus 2 times 1, which is equal to, in this case, 6t plus 2. People, are you with me? Are you happy with that? Okay. So if the expression is in terms of x, if x equal to the expression f prime x is the notation for the derivative. If the expression is in terms of t and ft is equal to the expression, then f prime t is the derivative of the expression. That is the notation that needs to be used. Are you happy with that? Now we're going to use the same rule, and we're now going to use a different notation. Okay, before I use a different notation, I just want to make things a little bit easier. The second law, second rule, if fx is equal to a constant, then f prime x is 0. The derivative of a constant is 0. Is that clear? For example, If I say to you, if x is equal to 3, then the correct notation for the derivative is f prime x. The derivative of a constant is 0. Okay, that's all. Only those two rules. Let's quickly have a look at this, and now I'm going to use those two rules, but a different notation for the derivative. Have a look. If I say to you, y is equal to 3x squared plus 2x minus 1. Now, people, take note. I'm asking you to find the derivative. Now, if y is equal to the expression, the notation for the derivative is dy over dx, because I am going to differentiate to x. If ft is equal to this expression in terms of t, f prime t is the derivative of t in the expression. Are you happy with that? So if y is equal to the expression, but I'm going to differentiate for x, then it's dy over dx. That's the correct notation. Now we're going to use the same rule. We're going to say exponent times coefficient. Keep x, subtract 1 from the exponent. Are you happy? We're going to say exponent times coefficient. Keep x, subtract 1 from the exponent. Derivative of negative 1. What is negative 1? A constant. What is negative 1? A constant. And what is the derivative of a constant? 0. So therefore, dy over dx of negative 1 is 0. Are you happy? Now this here becomes 6x plus 2, x to the power of 0 is 1, correct? 6x plus 2. People take note. I'm going to make it even easier for you. Let's quickly have a look here. We're still using the same rule. I'm just saying to you, if the exponent is 1, the derivative is the coefficient. If the exponent is 1, the derivative will be the coefficient. That's just a lot easier than all those other steps. Is that clear? Right. Can we reinforce that in the following? Let's quickly have a look. Here we're going to say y is equal to x plus 3, x squared plus 3x minus 1, or plus 1. Right. What notation will we use here? dy. If y is equal to the expression, what's the notation? dy over dx. Now help me, please. What is the derivative of x squared? 2x. You say 2 times 1 is 2, keep x, subtract 1 from the exponent, 2 minus 1 is 1. If the exponent is 1, what is the derivative? The coefficient, which is 3. What is the derivative of 1? So the answer is 2x plus 3. Are you happy with that? All right. Now people, I'm going to do one more y, and then I'm going to give you the third notation. Okay, because I know you can handle it. All right. Let's quickly have a look at this. If I say to you y is equal to, we're going to make it a little bit more complicated. We're going to say 3x cubed plus 2x squared minus 1 over x plus 3. Okay, now people, I'm going to give you a further rule. If we are going to differentiate to x, we cannot differentiate x if it's in the denominator. We need to take it to the top before we can find the derivative. Okay, what is the notation for the derivative? Help me, please. dy over dx, correct. But people, I told you, what must we first do? We first need to take the x. We cannot differentiate for x. Okay, let's make it like this. If x is in the denominator, we cannot differentiate. A constant can be in the denominator, but not x if we're differentiating it. So let's first take it to the top line. So this becomes 3x cubed plus 2x squared minus x to the power negative 1 plus a third. Correct? People, you are fantastic. Anybody tell you that today? If they haven't, they're missing it completely. Right. Let's quickly have a look here. Find the derivative of 3x cubed. 9x squared. Fantastic. 3 times 3 is 9. Keep x, subtract 1 from the exponent. What's the derivative of 2x squared? 4x. You say exponent times the coefficient, keep x, subtract 1 from the exponent. And how do we find the derivative of that? It's not 1, it's negative 1. So we say negative 1 times negative 1. Exponent times coefficient is plus 1. Keep x, subtract 1 from the exponent. Minus 1 is minus 2. Derivative of a coefficient is 0. Correct. Now people, they will most of the time, they will not ask you to write your answer with positive exponents when you differentiate using rules. So you can leave it there. If, however, they did, which is unlikely because it hasn't been like that for many years, where they ask you to write your answer with positive exponents. If they did, the answer would be 9x squared plus 4x plus 1 over x squared. Now that lady that asked me to explain it, do you understand? The exponent is negative, and x is found in the numerator. So how do I make the negative exponent positive? I just take it to the denominator, and I leave the coefficient of 1. I leave the coefficient of 1 in the numerator. Does it make sense? Are you happy with this now? Do you understand the different notations? People, there's one more notation. Let's do that one more notation, and then I'm going to show you that anything will always fit into 4 rules. Okay, this is the absolute foundation. But when you differentiate by means of rules, everything will fall into 4 rules. Let's quickly just do one of these, and then I'm going to show you that. People, at the end of this, you must walk out with 7 marks today. 7 marks is what you're going to put in your pocket in this exam, because it's easy. Let's quickly have a look at the following. If the expression is dx is equal to 3x to the power of 4. Right, now people, if dx means find the derivative. So when I differentiate, I drop dx, that is the notation. So it's exponent times the coefficient, keep x, subtract 1 from the exponent. So when they say dx of that, when you differentiate, the line in which you differentiate, you drop dx. Is that clear? I'm going to give you another one. For the people that have not done calculus before, you will, when you work through the book, you will come into contact with this and it will become more familiar. Just have patience in terms of 2 or 3 sums on this. Dx is equal to minus 3x cubed plus 4x minus 1. Let's make it plus 4. All right, people, let's find the derivative of that. Who can help me? When you find the derivative, you drop dx. What is the derivative of negative 3x cubed? Negative 9x to the power of 2. If the exponent is 1, the derivative is the coefficient, so it is. The derivative of a constant is, so the answer is negative 9x squared plus 4. Are you happy with that? I repeat, to find the derivative of this, we say exponent times the coefficient is negative 9. Keep x, subtract 1 from the exponent. If the exponent is 1, the derivative is the coefficient, which is 4, derivative of a constant, 0, and I'll simplify it. Are you happy? Right. What I'm going to show you now, people, is that everything will fall into the following rules. They cannot ask anything else. So what I'm saying to you is, they say in the following, determine the following. It's in your notes, and it is found on the 2nd page. Okay, right. Let's quickly have a look at this. People, 4x minus 3 squared means 4x minus 3 multiplied by 4x minus 3. Are you happy with that? Right. Now, people, at university, they will teach you the multiplication rule. But here at school, we got to bypass it. And how do we bypass it? If there's multiplication, multiply out before you differentiate. So this here becomes 16x squared. This here becomes negative 12 is negative 24x plus 9. Okay, so when there is multiplication, the rule is multiply out before you differentiate. I've written the rule there. Rule 1, multiply out before you differentiate. Now, can someone help me, please? Can I get a volunteer that will differentiate for me? That Eunice girl there, thank you. 1, 2, 3, 4. That lady there. Can you differentiate 16x squared for me? That's you. Correct. 2 exponent times coefficient, 32, keep x. Just like that, subtract 1 from the exponent. What is the derivative of negative 24x? Negative 24. If the exponent is 1, the derivative is the coefficient, negative 24. What's the derivative of a constant? 0. So the first rule is, if there is multiplication, that squared means that times itself. Multiply out before you differentiate. Only at university do they teach you the multiplication rule. Is that clear? Right, the next one. Number 2. Right, I need your attention on this one. People, we already said we cannot differentiate for x if x is in the denominator. So here we had to get rid of it. Here it was easy to get rid of it. Here we had to differentiate, but x is in the denominator, so we used the exponential law and we took that to the numerator and we changed the sign of the exponent. That was easy. All right, we just used exponential laws. But here we've got an expression over a monomial, one term, in terms of x. And we cannot differentiate for x if it's in the denominator. So what must we do to get rid of that x in the denominator? We're going to write each term over the denominator. We're going to say x squared over 2x squared, correct? Minus x over 2x squared. Minus 6 over 2x squared. People, are you happy with that? So what I did is I wrote each of the terms over the denominator. Now I'm going to simplify. And then I can differentiate. So the x squareds cancel out and this here becomes a half. Agree? This here, people, x divide with the same base. You're going to keep the base and subtract the exponents. You keep the base, subtract 2 minus 1 is 1. And yeah, this 6 divided by 2 is 3 over x squared. Correct. I'm not yet finished. Do you see x is in the denominator, x is still in the denominator. Now I'm going to use my exponential laws and take it to the numerator. So this becomes dx of a half minus 1 over 2 x to the power negative 1 minus 3 times x to the power negative 2. Correct. Are you with me? People, I cannot differentiate for x if it's a denominator. So if I take it to the top, I need to change the sign of the exponent. This here is a positive exponent, x to the power positive 2. I took it to the top and I changed the sign to x to the power negative 2. I used my exponential laws. Now I'm going to differentiate. And when you differentiate, you drop dx. What's the derivative of a constant? 0. What is the derivative of negative a half x to the power negative 1? we're going to say it is negative 1 times negative a half is plus a half. We're going to keep x and we're going to subtract 1 from the exponent. Negative 1 minus 1 is negative 2. And we're going to say negative 2, the exponent is negative 2, times the coefficient, negative 3 is 6. Keep x, subtract 1 from the exponent. Are you happy with that? Right. And lastly, people, you can keep it like that with a negative exponent unless they ask you to write it with a positive exponent. Are you happy with that? Okay. So the rule is, if you have to differentiate and there's a monomial in terms of x, how do I get rid of it? Write each term over the denominator, simplify, and then differentiate. Is that clear? The third rule, people, this is all the rules. Nothing else can be asked. If it's multiplication, multiply out before you differentiate. If you divide by monomial in terms of x, how do I get rid of it? Write each term over the denominator, simplify, then differentiate. The third rule is the following. If you've got a binomial in the denominator, so if we can say to you that fx is equal to 3x cubed minus 7x squared minus 6x over 3 minus x. Right, now let's quickly have a look here. People, I cannot differentiate for x if it's found in the denominator. It's not a monomial. If it's a monomial, it's one term. How did I get rid of the monomial? I wrote each term of the denominator, simplified, then differentiated. If it's a binomial, I need to factorize, simplify, before you differentiate. So I'm going to say, factorize that. The first step in factorization is the highest common factor. Then I look for the difference of two squares. Then I look for the trinomial, then the sum and difference of two cubes. So here I take out the highest common factor, which is x. What am I left with? 3x squared minus 7x minus 6 over. I'm going to change 3 minus x to x minus 3, so I take out a negative, correct? And negative times x is negative x. Negative times negative 3 is positive 3. Now that will give me x minus 3 as one of the factors. So it is x. 3x squared is 3x multiplied by x. The factors of 6 is negative, it is plus 2 times negative 3. Now let's quickly have a look. 3x squared, negative 9x plus 2x is negative 7x, and this is negative 6, over negative bracket x minus 3. People, do you see that that cancels out? Agree? Now, the negative, remember the negative can be put negative a over b. It's in the middle. It can be negative a over b numerator. It can be a over negative b. So you can either put the negative in the middle, the top, or the bottom. So because the negative is at the bottom, I'm going to put it to the top. So it's negative x bracket 3x plus 2. Now I first need to multiply out. My first rule. First multiply out before you differentiate. So this here is negative 3x squared minus 2x, correct? And when you differentiate, you say f prime x, and that is equal to, please differentiate negative 3x squared, negative 6x. Exponent times coefficient, negative 6. Keep x, subtract 1 from the exponent. What if the exponent is 1, what is the derivative? The coefficient, negative 2. So that is your derivative. Is that clear? Are you happy with it? Right. Now I'm going to do the last rule. The first rule is you multiply out before you differentiate. If you are dividing by a monomial, how do I get rid of it? And the monomial is in terms of x, for which I need to differentiate. I write each term of the denominator, simplify before you differentiate. If it's a binomial, you factorize, simplify before you differentiate. And the last one, you get rid of square roots and cube roots. Right, let's do that one. People, when you walk out here, it's 7 marks that you've got today, and that you're going to get 7 out of 7 for all the exams to come. Is that clear? Nothing else can be asked. Short little rules, apply it, and you've got the answer. Last one. They say, determine dy over dx. That means determine the derivative if y is equal to 1 over 2 the 4th root of x cubed. Okay. Now, people, can I get your attention here? I need to explain exponents here before I can do this. Otherwise, you're not going to understand it. All right? Let's quickly have a look here. Okay, I'm going to say to you x to the power of a half. What does that mean? The square root of x, correct? You don't have to put a 2 there if it's the square root. If I say to you x to the power of a third, it is the cube root of x. Does everybody understand that? Right. If I say to you x to the power of 3 over 4, I'm going to break up that. I'm going to say it is x to the power of 3 further raised to the power of a quarter. A base to an exponent, further raised to exponent, keep the base, multiply the exponent, 3 times a quarter is that. Agree? And what is a quarter? It is the 4th root of x cubed. Does it make sense? Does it make sense? Right. This x to the power of 3 quarters, I can break it up. The denominator tells me it is the 4th root of x cubed. This here is x cubed raised to the power of a quarter. 3 times a quarter is 3 quarters. So this tells me it is the 4th root of x cubed. Are you with me? Do you understand that now? Using that theory, let us apply it to the sum. We cannot differentiate. They say determine dy over dx means determine the derivative. If y is equal to that, do you see x is in the denominator? So I need to get it out of the denominator. So what am I going to do? I'm going to say y is equal to 1 over 2, correct? And this here becomes x cubed raised to the power of a quarter. People, I'm doing it line for line. Agree. It is x cubed. The 4th root of x cubed is x cubed raised to the power of a quarter. You agree with me? So this here becomes 1 over 2, and x to the power of a base to an exponent, further raised to exponent, keep the base, multiply the exponent. It's still in the denominator. I just got rid of the 4th root. Now I must take it to the top. So I apply my exponential laws. So it's 1 over 2 x to the power negative 3 quarters. If the exponent is positive in the denominator and I move it to the numerator, I change the sign of the exponent. Are you happy with that? Now that y is equal to a half x to the power of negative 3 quarters, I'm going to say dy over dx. Now I'm going to find the derivative. Because x is no longer in the denominator, it's in the numerator. Now I can differentiate. Now I want someone to help me. Differentiate that for me, please. It is exponent times coefficient is negative 3 over 8. Keep x, subtract 1 from the exponent. Negative 3 over 4 minus 1 is minus 4 over 4. It's negative 7 over 4, correct? So that is your final answer. Does it make sense? I cannot simplify that final answer. I don't have to write it with positive exponents. So the 4th rule is always get rid of the 4th root the cube root, the square root. I got rid of it. Now I can differentiate. Are you happy with that? Right, people, that's 7 marks. You're all going to get 7 out of 7 in June, September, as well as November. Next week, I will focus on differential calculus, all the possible questions. When it comes to basic principles and tangents, that is another 7 marks. And then we're going to go on to the cubic graph, which is 15 marks, where you either need to sketch it or interpret the cubic graph for 15 marks. We are working on 35 marks of the final exam question. Have a good day.